Now, what kind of sucks about estimation is I used to always be able to talk about tip, leaving a tip somewhere at a restaurant, at a bar, whatever, leaving a tip. A lot of times nowadays, restaurants actually list like several options at the bottom. If you want to do 10%, 15, 20, they actually tell you what it is. So they've taken away your ability to practice math. That kind of sucks. But if you wanted to leave, let's just say like 15% tip, and the meal was cost like, I don't know, $49.
It's about $7.50.
So again, the important thing about this class is showing me the work. So how would I do that?
Well, I moved it 10% over and then took that 10% half.
Wow.
All right, so let's all catch up on that, because that's actually the way I would do it too. So what the hell did he just say? He said 10% of something is easy. Because to get 10% of something, that's 10 hundredths, it's 1/10 of something, right? And that just moves the decimal over once. When you divide by 10, you move the decimal over. So if I do 10% of 49, what's that? $4.90. And to even make this better, I just make that 50. Let's make it 50.
Yeah.
We want to do truly just pure estimation. Now I want 15% tip. So now I need 5%. And then I can add them together to make 15. Do you guys see how that works? If I know 10% is $5, how much is 5%? It's got to be half of that. How are we doing? That's kind of cool. I mean, that's the way you can play around with percentages. And then if you add them together, you get 15% of 50, 750. You know, and if you really like them more than that, you can give them 8, or you can actually just make it 20% from the beginning. 20% is nice. You do 10% and then double it, right? So that idea of building percentages is really cool. Because you can base it on 10%, it's easy. So that's one kind of quick estimation. Now, I'll show you 2 hard and fast rules. And it's funny I say it like that, because then I'll show you where you can break the rules. But there are 2 definite things I have to see from you. Beyond those, you could do whatever way you want to, as long as I see what you're doing. Right? So let me try to explain myself. Just basically what I'm always doing. When you multiply 2 things, little musical interlude. When you multiply 2 things, let me give an example, an easy example. What's 4 times 5? Neato. If I want to make it still 20 and I take the 4 down to 2, so that went down, do you guys see what I'm saying? If I make the 4 go down to 2, what do I have to make the 5 go to make it still 20 in the end? So if I take 1 down, the other one's got to go up to kind of counterbalance that. Does that make sense? So this has got to play into our estimation, right? If I take that 4 down to 2, I've got to take that 5 up to 10, so I get the same answer. Now, how does that apply to our problem? We'll see something like, find 38 times 409.7. And not even that, I won't say find, I'll just say estimate. So here, this is a nice thing. I'd have to do that in a calculator really, or want to do it the long way out, right? But just to get a quick estimate, how would you want to change things? Make them nice whole numbers. You take the 38 and make it 48. You went up there, so you better go down there, so overall it's kind of balanced out. Do you guys see that? That's one of the main things. If you take these both up, I'm going to have to take some points off because you're going further away from what the right answer is. Right? You want to kind of balance out what you're doing. If you take that guy up, you better take this guy down. And the nice thing is they're both kind of nice and close to round numbers. 4 times 4 is 16. 1, 2, 3 zeros. Now who's got a calculator out? What is 38 times 409.7? Just out of curiosity. 38 times 409.7. 1556. 8.6. That's pretty damn close, right? Okay, cool. This number I really do not want to see on your homework. I always get somebody turn in 1.2 and they don't estimate anything. They just put it all in there. That's totally the opposite of what the problem is. Do this on the side. I also get people do this and then they round that number. Is that estimating? Of course not. You didn't estimate. You just rounded what you got from the real answer, right? Estimation is all about this step right there, and that's what I got to see. I got to see what you did to the problem to get to where you ended up. Don't just put 16,000. That's not enough. I got to see what you did, right? You can always do this, though, just to make sure you're close. If I got 80,000 here and the answer is that, I'm like, holy crap, what the hell did I do? But don't write that number down.
So you just picked 400?
Well, 38, I wanted to round it up to 40. Since I rounded that one up, I have to round that one down so it balances back out.
I know it was like the first one, like you went down by 2, so then it times
Up by 2?
Well, the first example.
Oh, here.
Yeah, so you times the 5 by 2, but I don't get how you.
Now, don't. I wanted you to get the idea that if one goes down, the other one's got to go up. There's no way I can be as specific as what multiple did I actually go up by and then go down by the multiple of that. No, I'm not going to do that with 38 and 40. But I did take that one up, so I better round this one down. So overall, I'm still pretty close.
Will there ever be a time when they both go up or both go down?
We'll do a problem like that. That's what I was saying about sometimes you might want to break the rule.
Okay.
Yeah.
I think what she was trying to say, which was kind of my question too, is like what made you decide to choose 400?
Because it's the closest whole number that's below this.
So you would round it to like 405? No.
You want something that's really stupid easy to do in your head,
Okay.
right? Because I'll have somebody that rounds this to 409. I rounded it down, Jeff, and then I'm like, well, can you really, do that truly easy in your head? Maybe not. You want to make it as round as you can.
Yeah.
Yeah.
Oh, that was just it. Yeah.
Okay, cool. So that 400 didn't come out of nowhere. I know I had to round that one down, and that's the next purely whole number down.
So you couldn't do 401?
I wouldn't want to do 401 again because it's not as easy to do 40 times 401 as it is to do 40 times 400. Right? It wouldn't be wrong, but you want to make it as round as possible. So you can do it real quick in the head. Right? So that's one rule. When you multiply, if one goes down, the other one's got to go up. What about when you divide? So let's start off. Now, does everybody understand what I was trying to do here? I just wanted to show why the rule was what it was. You're not going to see a problem like this because you don't have to round this stupid thing. Right? But now it makes sense if one goes down, the other one's got to go up. So if I divide, so for example, if I have 30 divided by 6, that's 5. Well, if I make 30 go down to 15, we'll have to do with a 6 to make it still come out to be 5.
Rounded low.
It's got to go down to 3, right? They both got to. It only makes sense because what do I do with fractions? I can reduce them or build them up to make LCDs. They both change in the same direction to keep the proportion the same. Does that make sense?
Yeah.
So I took the 30 down. The bottoms then got to also go down. So when you multiply to keep the balance, they have to go in opposite directions. So because if you build them both up, you got way too big. Build them both down, you got way too small. Division, they've got to go the same direction to keep the proportion the same. So a problem you would actually see would be like this. Like what, Jeff? I don't know. 691.87 divided by 9.35276. Yuck. But again, which direction do you think I'm going to want to round? Up, because the 691 is almost what?
700.
And this little symbol here, you've probably seen that before, that means approximately, right? Or you see it sometimes over an equal sign. Approximately equal to. So that I can take up to 700, so I better do what with the bottom?
Right about that.
Bring it up to 10. Sweet. And that just kicks so much ass. This is where I get people doing like 690 divided by 9. And I'm thinking, did you actually do that in your head? You could if you really sat there and thought about it, but you want it to be something you can do very quickly in your head. Make them both very round. Of course, what's 700 divided by 10? Kick ass. Just kill a 0. Yeah. Cool. Those are the only two rules that you really have to follow. Everything else, as long as you show me what you're doing, I'm fine with it. Cool? Cool. So here, real quick, I'll show you a few places where you might want to break the rule and how to be telling me that you're breaking the rule. And then I'll let you guys try a few out on your own. Okay. So here's a few places where you might want to break the rules. This is what you don't see a lot of in a class like algebra, because you can't break the rules in algebra. Otherwise, you end up at a wrong place. Here, we're a lot less strict, really, because we're not trying to get exactly the right answer. There should be some ways that can finagle things. Yeah?
Wasn't that division one breaking the rule because you both went down?
No, that's the idea with division, though. Multiplication, you've got to go,
Oh, okay.
and division, you've got to go the same way to keep it the same answer. Right? Cool. So those are the two rules. So what if I had a problem like this? What if I had like 9.98 times 1999.13?
You break the rule, it's easier just to.
Yeah, they're both so freaking close to the next number up. I'm breaking the rule a little bit, but what does that mean then if I make this go to, let's actually go, let me just put it next, make them both go up, so this will be approximately 10 times 2,000, which is, just add another 0 on the end, right? If you break